let's dive into ArcGIS Pro. So hopefully you can all see ArcGIS Pro. What I'm going to do is kind of look at various different pieces of data visualization, and particularly kind of spatial data visualization, and all through a kind of potential use case of we're trying to choose a new retail store location. So yeah, I'm going to be using a retail store, but it could be trying to find a new hospital or warehouse or a new real estate site. So yeah, kind of anything where we're looking at kind of catchment areas and access to population and customers and suppliers and employees and all of that kind of thing. But yeah, for this one, it's going to be a potential retail store. And we're going to look at various different data sets to try and make a decision around which of these sites is most likely to be the most successful one to choose. So we're going to look at access to population. We'll look at access to sort of some more demographic data specific to those areas. We will look at how accessible they are to where our suppliers are based. And we'll look at access to our employees, because they're going to have to commute to this site. And then once we've kind of chosen the site we want to go ahead with, we'll look at kind of building some visualizations to sort of support that decision and for kind of use as we go and select that site. So I'm going to be using kind of a combination of parts of the TravelTime platform added into Pro, also some other general tools within Pro, and some other sort of data sets. So I've got some data loaded in here already, but we'll kind of go through those as and when they become appropriate. But the first thing we do have loaded in here is a layer of the sites that we are considering. So we've loaded in 10 different or 9 different sites across the UK, all based in kind of large urban areas as potential retail stores. And the first thing we want to do is to look at kind of the access to population and the demographics for each of these sites. And we're going to do this for public transport. So the TravelTime tools kind of support analysis for all different types of transport. So driving, walking, cycling, public transport, and we'll look at driving in a sec. But initially we want to look at what are the catchment areas for people traveling to each of these potential sites by public transport, because yeah, we've realized that that is the most common method of transport to get to our existing stores. So we want to create some isochrones or trade areas around these sites. So we're going to start in our catalog pane here, and we have a TravelTime Platform section of tools, and you can install these running kind of an installation file, which we can send you after the webinar. And we're going to use our time map tool. So this is the ability to create catchment areas based on travel time instead of on distance. And we want to run it around this layer of potential sites. Pick an ID. We want to use a time zone, so we use UTC. We want to calculate catchment areas for people arriving at these stores, and working out where they could set off from and get to each of our stores. And let's say we want them to arrive at midday. We want to do public transport areas, and we're going to do a 60-minute catchment area. And we can choose if we want to keep fields from that, from the table of these potential sites. So these are all the fields within that file, and we're going to just keep the city for each of these sites, so we can kind of more easily identify them later on, and will help with our kind of further analysis. So we run the tool. And yeah, we are kind of, at TravelTime, we're not sort of GIS experts. So we've kind of built, hopefully, tools that are pretty easy to use, even for kind of non-GIS users, sort of more general business users. And yeah, not difficult to configure, and yeah, pretty simple to get up and running. So we've now got our public transport catchment areas around each of these sites. So I'm just going to go and rename this. Kind of the real value of these catchment areas is now we can use these to filter other data sets. So rather than just the visualization, which is a good starting place, we actually want to know kind of what is in these catchment areas. And the first one we want to look at is population. So I've got a file here, I'm not going to open it up, which is basically every postcode across the UK and the population of those postcodes from the census. So what I want to do is basically calculate the total population within each of these catchment areas based on this postcode data. So we're going to use a tool in ArcGIS called Summarize Within. This is going to basically let us select the layer of polygons we want to use, which is this public transport areas. The features we want to summarize. So it is our UK population data. And then within this, this data, we have a load of different fields that we can summarize. And we want to use the total persons. So this is the total population of each of these postcodes. And we want to sum that up. So what this is going to do is for each of these 9 sites, it's going to count up the total population of all of the postcodes reachable within the area for that site. This tool can take a little bit of time to run because there are 1.4 million postcodes in the UK, and it is trying to work out which ones are in each of these different areas and then add up the population that exists within each of those postcodes. So yeah, this might take a minute or so. And again, yeah, this is all open data, this population data, but I can share it with you after the webinar so you can load it into Pro yourselves and start playing around with it. There is obviously a new census happening this year. So yeah, at some point there will be even more up-to-date data, but this is from the 2011 census, which is the most recent one. Just let this run away in the background. I should stress, yeah, this is a tool that's just part of Pro. It's not a TravelTime tool that we have built. Cool. So we get a new layer added that kind of looks the same. It's just showing the same isochrones. But if we open up the attribute table for these, what we now have is our 9 cities. So this is why we retained the city name when we created the isochrones, so we could identify these in this next layer. The count of points, so this is the number of postcodes within each of these catchment areas, and the total number of people. So we can start kind of sorting this and getting a really good early sense of what is the reachable population were we to open one of these stores. So yeah, comparing London, where there's over 4 million people within that 60-minute public transport area, to if we opened a store in Cambridge, only 180,000 people within that catchment area. So that's a kind of useful first start, is we're getting a sense of reachable population. The next data set I'm going to filter is a more demographic data set around income distributions. So this is a layer from the Esri Living Atlas. So again, if you have an ArcGIS subscription, you can get hold of this layer. And it breaks down areas based on population, based on income distributions. And again, we want to now filter this just to look at the income distributions within those public transport areas that we created. So I'll just hide those for now. And we're going to use another tool from ArcGIS called Overlay Layers. again, this is a very, very simple tool. The input layer is the one that we want to filter. So we're going to use our household income layer. And then the overlay layer is the layer we want to do the filtering. So this is our public transport areas. There are various different ways you can run this. So you can kind of use arrays to take away this from the larger area. But we're going to do the intersect and just find the areas where these overlap. And we run this. So this one is much faster. And what this will do is add another new layer to the project. And this is showing us the income distributions for these different reachable areas. So initially we just had a sense of kind of how many people live in each of these catchments. But now we can start digging more into what is the sort of demographic profile of these different catchment areas. Potentially, you know, we're targeting different consumers at different levels of the income spectrum. This can give us a really helpful view of you know, how likely a store is to be successful or attract the right demographics for what we're trying to market and to sell. Let me just match this. And one other thing I wanted to show you here is adding what's called definition queries. So in some of these areas where they overlap, it can be kind of a little bit confusing to see which isochrone is which. So there's a really kind of helpful tool in Pro. So if we select this layer, and we go into data, and then definition query, and we just click this little build definition query. What this lets us do is kind of set a drop down where we can kind of filter for these isochrones one at a time. So say we just wanted to look at the London area, we can call this query London. And what we want to do is we want to say we want the city to be equal to London. Apply this. Okay. It sets that query initially, but it also adds it to a little drop down here. So you could add kind of a number of different stores here, and you can just toggle these on and off. So if you want to see all of them, you can remove it. But if you want to kind of dig down and see, okay, let's just look at one at a time, we can see London. And this is where it's really helpful because this catchment area is obviously part of maybe the Reading store. So we're just focusing on the London area to get a sense of what is just specific to this store's catchment area. But let me hide that for now. So now we've got a sense of kind of access to population and potential kind of demographic patterns of those access areas. The next thing I want to look at is access to suppliers. And for this, we don't want to use public transport. Yeah, we know that suppliers have to get to the stores driving. So we are going to create some driving areas around each of these potential sites. So let me just zoom out. So again, we're going to use the same tool from the TravelTime toolbox. So this time map advanced tool. Again, we'll run it around these potential sites. ID again. Again, we'll use UTC. To arrive at each store. Again, for kind of consistency, we'll just do midday again. This time we pick driving. And we're going to do a 45-minute catchment area for driving around each of these potential sites. And again, we're going to just retain this city field so we can more easily identify each of these different catchment areas. And we'll run the tool. So whether you're doing public transport analysis or driving or walking or cycling, you kind of use the TravelTime tools in exactly the same way. Just changing the travel mode. There's no kind of configuration of public transport network data or GTFS data or anything like that. It's all just done in the background for you. So now we have our driving areas. Just rename this. And what we want to use these areas to do is to work out how many of our suppliers fit into each of these different stores' driving areas. So we've got a layer here where all of our kind of known suppliers are. And basically what we want to do is count up how many of these suppliers fit into each of these different catchment areas to work out which one of these sites gives us kind of best access by car or by truck to our suppliers. So we are going to once again use our summarize within tool, but just in a slightly different way this time. Again, we select our polygon, so we're going to use the driving areas. And this time, rather than looking at the population data, we're going to use these supplier sites. And we're not going to summarize this time. So last time we selected the population and said sum it up. So it kind of went through all of the postcodes and added up the population. This time, all we want to do is just know how many of these there are within each of these areas. So we don't need to kind of summarize any data. We just want to simply count them. So we can just run this. It will be hopefully a bit quicker than the population summarize. And again, we get a new layer added that looks very similar to our driving areas. But once again, if we open up the attribute table, what we now get is, again, for each of these cities, we get a count of the number of points, in this case, the number of these supplier sites that fits within each of those driving areas. So if we just sort this descending, we can now see that even though London gave us by a mile the best access to population and by public transport, because it's in the centre of London and its driving area is actually quite constrained, it's not giving us the best access to where our suppliers are. This Birmingham site has 31 suppliers within a 45-minute drive, whereas the London location only has 18 within a 45-minute drive. And kind of down at the bottom, the Cambridge site, there are no suppliers within a 45-minute drive. So this is probably one we want to discount straight away. Cool, so we're kind of honing in on potentially the sites that we want to look at, probably Birmingham or London. But there's one more piece of analysis we want to do, which is to look at how commutable they are for our employees. So we want to know how long is it going to take our employees to commute to these different sites. So we can remove all of these. And we have a new layer here, which is where all our employees live. Oh, I think I've got a filter applied to this. So we've got 1,000 or so employees spread all over England, Scotland, Wales, and we want to do a commute analysis for each of these employees to each of these potential sites. And we're going to use a different TravelTime tool this time. So again, in our catalog pane, in this same TravelTime toolbox, we're not going to use time map, we're going to use time filter. And what time filter does is essentially calculates loads and loads of travel times between the layers in two different, the points in two different layers. And you can kind of set a cutoff for what you want the maximum travel time to be. So we're going to look at journeys that set off from our employee homes. Again, we'll pick an ID, just use the employee ID. Again, we'll do it for UTC. We want journeys that arrive at 9 in the morning. So 9 AM arrival time by public transport. Again, we could do a driving commute analysis if we wanted to, or cycling or walking, but we'll do public transport for now. And we can set a maximum travel time that we know that people aren't going to commute for 4 hours. So if we just say 90 minutes, for example, that means that any of these journeys that are outside of 90 minutes will just be unreachable, and we can kind of discard them. So we just want to know how many employees could commute to each of these different offices within 90 minutes. And we need to arrive at these potential sites. Again, we'll use the city ID so we can identify them in the output and run this tool. So this is probably where the travel time tools are most powerful, because this can calculate thousands and thousands or tens of thousands of travel times incredibly quickly. So yeah, this is doing from, I think, 800 or so employee addresses to those 9 offices. So yeah, a few thousand travel times, and then filtering them based on 90 minutes or less. Shouldn't take too long. So we're not going to bother with the visual so much, but what we do want is the attribute table. And each of these rows is one of our employees to one of these cities, whether it's reachable within that 90 minutes cutoff we set, so 1 or 0, and what the travel time is in seconds for that commute. One thing I'm going to do here is actually add a calculated field to turn this travel time in seconds into minutes, because yeah, everything in the travel time is always returned in seconds, but yeah, as a sort of human readable value, minutes is often more useful. So I'm going to show you how to do that. So there's this little calculate field option. And we want to create a new field. So let's call this commute time. We can choose what type we want this field to be. So I don't want lots of decimal places. So I'm going to choose this small integer option, which will just give us no decimal places. And then we just have to write the expression to do the calculation. So what we want to do is basically divide the travel time by 60 to give us the travel time in minutes. So we say, take the travel time, divide it by 60, click apply. And what we now have It's only done it for those. Let's try that again. Let's do it for all of them. So commute time. Let's take our travel time, divide it by 60. And make sure this is just this short, small integer. and run this. So yeah, we've now got it applied to all of our travel times rather than just the one I had selected. So apologies about that. Let's remove this one. So what we now want to do is kind of analyze these travel times a little bit closer. There are kind of ways to do this in ArcGIS Pro, but another option that I kind of prefer is to basically export this into Excel, and then we can look at it in there. So there is a tool in ArcGIS to take an attribute table and turn it into an Excel table. So it's called Table to Excel. So we use this layer we just created. We can choose where we want to save it and what we want it to be called. So let's call it something slightly more memorable. And then we'll run this tool. So nothing actually happens in Pro because it's created an Excel document. But if we go to that location, so go into our project folder, we have this new employee commute times Excel document. And this is just that attribute table turned into Excel, but we can now run some analysis to work out which of these offices is the best for our commute times. So what I'm going to do is use a pivot table. Okay, and this just lets us kind of slice and dice that data to get all of the kind of insights that we might want. So we want a table that has the arrival locations. So this is the offices or the sites that we're arriving at. And there's a couple of things we want to do. First of all, any of those commutes that were more than 90 minutes away, we marked as unreachable, and they will therefore be given a travel time of 0. So to work out how many are reachable, we want to just filter out any that have a commute time of 0, just because they're the ones that we're discounting because they're outside of that cutoff that we set. So we're just going to say we want everything apart from the ones with no travel time. And then we want to do a couple of things. We can count up how many there are. Oh, we want to just not do a sum of this, but just count it up. So this is now how many of those employees are within that 90-minute journey time. And also we want to know a bit more detail about what those commute times actually are for those people. So we could do not the sum of the commute time, but say the average commute time. And just format it slightly nicer. And what we now have is, for each of these offices, how many people live within a 90-minute commute by public transport? And for those people, what is the average? So in London, there are 165 people within that 90 minutes, and the average commute time for them is 57 minutes. In Birmingham, there's 40 people, but with actually a slightly lower average commute time. So we can keep slicing and dicing this to get a really granular picture of what is the best option in terms of sort of employee commutability for these different sites. I'm now going to go back into ArcGIS. So say we kind of use all of this data, we compare access to population, the demographics, access to suppliers, employees, and we decide that we want to go with the Birmingham office. So we're now going to just do a couple of pieces of kind of visualization specific to that office. to kind of help promote the decision that we've made. So the first thing I want to do is just hide the other sites. So we're just looking at this Birmingham site. So again, we use this query definition that we used earlier. So we go into build a definition query. And we want it just to be where the city is Birmingham. We could just create a new layer with just the Birmingham office in, but this means that kind of if we want to go back and start looking at other ones, they're still there, they're just hidden temporarily. So now we have our Birmingham location. Now we want to, okay, well, yeah, there's two things we're going to do. One is there are a few kind of key senior management employees, and we want to look at specifically what their commutes would be by public transport to this office. So in our employee homes layer, we've actually got a field that lists kind of the employee type, so what seniority they are. And again, we're going to build a definition query to just filter out the employees who are kind of senior management, so we can just focus on them and have a look at what their commutes would be like. Again, we use our definition query. Just create a new one. And we find that sort of seniority field. So it's employee level. And this is all just data that we had kind of in the spreadsheet when we first uploaded it into Pro. And we want senior management. Apply. And what that's done is now just filter these employee homes for just those that, yeah, are senior management. And we basically now want to get a sort of visualization of what would their commutes be by public transport to this office. So yeah, some of these are going to be pretty long, but maybe they only come in once a month, and we want to show them what that journey would involve. So again, we're going to use the final one of the TravelTime tools in our catalog pane. So we've looked at time map, so creating isochrones. We've looked at time filter, which was creating all of those employee commutes. And this one, routes, is going to create the visuals of what these journeys would actually involve. So we're going to set off from employee homes, pick an ID, so maybe their postcode, again UTC, to arrive at this Birmingham site at 9 in the morning. We'll run it for public transport, arriving at potential sites. So it knows that we've filtered these sites, this sites layer and these employees based on the definition queries. So we'll only run the analysis for the ones that we've got filtered currently. And we want to display this output. There's various options, but we want to display it based on what type of transport is being used, so we can see, you know, where it's buses, where it's underground, where it's overground train, that kind of thing. And again, we can keep fields this time from both the departure layer and the arrival layer. So we don't really mind about the arrival layer because it's all this one office or site. But we do want to keep some data from the departure layers so we can identify which employee is which. So maybe we use their postcode. Or actually, the employee ID is probably more sensible. I'm just going to show you, so there are some advanced fields that actually exist on all of the tools I've been using. And you can kind of configure things like how long you want to let someone walk for as part of this public transport journey. So here, 5 minutes is a little bit low, so I'm going to say we'll let someone walk for 15 minutes. And we'll run this analysis. So this is often kind of how we see this routes tool used, is is not so much in the decision-making process. That tends to be the isochrones and the lists of travel times. This is more to kind of validate those results and give you a sense of, okay, what would that actually look like once we've selected that as a site. And here we get a nice visualization of what each of these public transport journeys will actually involve. And it gets broken down by the different transport types being used. And also, if we wanted to go into the attribute table, we can even get a full breakdown of what each of these journeys is. So we could kind of present this to this senior management team and just let them know exactly what the commutes would be for each of them. And each of these has the employee IDs assigned to it. So we could have a look at each one individually and see what their commute would be to this site. And the final piece of analysis I want to do is, so we looked initially at supplier access to each of these sites. Now we've selected a site, I want to have a look at which are the suppliers that are accessible from this site and what are the driving times from them to this site. So this time I'm actually going to just zoom in on this site. So we're going to create a driving area using the TravelTime tools, but rather than running it off a layer of points, because we only have one site now, there's actually an even quicker way of doing it. So we have this TravelTime Platform banner up at the top. And this lets us use the three pieces of functionality we've already used, so isochrones, the time filter, and routes, but it lets us do it by just clicking on the map. So because we're just doing it off one point, we can just open up our quick tool, say driving for 45 minutes to arrive at, I think we did for midday. And then we can simply just click on this location. And what we now get is a new layer. If we just zoom out to this layer, we've now got our 45-minute driving area just around this Birmingham site. And now we want to filter these suppliers based on which ones are inside this 45-minute drive and which ones are outside. So we're going to use, again, our overlay layers tool that we used originally. So again, we can just search for this. And as we did last time, the input layer is the points we want to filter. So it's our supplier sites. The overlay is what we want to use to do this filtering. So it's this arriving 45 minutes area we just created. And we run this tool. And if we just hide the full list of supplier sites, we now have just the suppliers that are within that 45-minute region. And so we can kind of go and see exactly who these are and kind of explore that further. Yeah, I think I'm going to leave it there just to kind of respect everyone's time. There are plenty of other things we could go and look at in terms of overlaying more data and playing around with the tools, but hopefully that is a sort of a really quick intro into how you can kind of combine some of the travel time functionality with other data sets like population and demographics, and then use other tools in ArcGIS Pro to filter them and overlay them and intersect them, and just start building up kind of really rich view of different sites and which one is the most appropriate for a new store or a new office or a new hospital or whatever it is that you are interested in.